So this is a good way of how we use them on. A question like this often comes up on the exam paper as well. It's a nice, easy one. So, empirical formula. So we said the empirical formula is equal to the simplest whole number is important, of atoms of each element present. So an example of that, so e.g. it could be CH or CH2. Something like that. It's just the simplest whole number ratio. Why would this not be an empirical formula? I can cancel down and that could become 1 and that could become 2. So that would not be an example, but these would. The molecular formula shows the actual number of each element present in a molecular compound. Now, questions at AS, what they do is they start by asking you to do this, and then they carry on and ask you to use your answer to calculate the molecular formula. So what we're going to do is we're going to do a couple of examples just so you're happy with doing those. So an example of that would be the one I had up here earlier, C2H4, which would be an example, or C6H6. Something like that. It's the actual number. Can anybody name C2H4? Name that molecule. Organic chemistry. Alkenes, alkanes. It's an alkene. It's got 2 carbons. Ethene. Yeah. So let's do an example, because these come up loads. So, e.g. Now sometimes they always give it as a mass, but sometimes they give it to you as a straight mass in grams, sometimes they give it to you as a percentage. Doesn't matter, works exactly the same way. Let's try and work it out for iron chloride. So iron chloride contains, so in my sample, I have got 6.71 grams of chlorine and 3.53 grams of iron. And I'm going to work out its its empirical formula. So the first thing I do is I work out its, do it as 2 columns. So you've got Fe and you've got Cl. And we're going to do the same to both. First of all, work out the mass which you've been given. So for iron it is 3.53 grams and for chlorine 6.71 grams. So that's my mass there. I need to convert those numbers into moles. Yeah.
Into moles. I think that you have to divide it.
Yep, that's right. What am I going to divide it?
The periodic table mass.
Yep, my molar mass. I need to convert it into moles. Right. So what am I going to divide 3.53 by? Sorry?
55.8.
Yeah, that looks good. Yeah, 55.8. And what am I going to divide chlorine by? 35.5. Yeah, so they're just my molar masses. So let's do that. So I've got, so you can calculate along with me. So I've got 3.53 divided by 55.8. Now, be careful. The answer is 0.06326, carries on. I'm going to keep it to 3 significant figures. Don't go any fewer than that, because otherwise your answer will come out wrong. Don't go to 0.06. Keep it at least 3 significant figures. Right, and my chlorine 6.71 divided by 35.5, that gives me 0.189. Yeah.
Now do we divide it by the smallest number?
Brilliant, yeah, because there's no point in me writing a formula, it's the simplest whole number ratio. These are whole numbers. So to get them to whole numbers, I divide by the smallest one. So that is still moles. To convert to a whole number, divide by smallest one. So let's do that. This one's the smallest one. 0.0633 divided by 0.0633 and 0.189 divided by 0.0633. Do you want to do that and let me know what you get? Hopefully you can work out that's going to be 1. Would you get 0.189 divided by this is? Sorry? So 2.9? Yeah. So 2.98 and then it carries on. That is pretty much 3. So the ratio is 1 to 3. So my empirical formula is equal to FeCl3. How can I work out my molecular formula? Can I do it at the moment? No, I can't. What do I need to know? I need my molar mass. Yeah, brilliant. So, let's say if the question said the molar mass is equal to 324.6. Work out the molecular formula. How would I go about doing that? Yeah, cool. So what I'll do is I'll work out the molar mass of FeCl3. And if I do that, that comes to 162.3 iron 3 chlorines. You can double check if you like. Let's just do that. 55.8 plus 35.5 times 3. 162.3. So that's not my molecular formula, is it? Because my molar mass is actually 324.6. So I then do 324.6 divided by 162.3. That equals 2. So the molecular formula is equal to Fe2Cl6, like so. Key thing to note, show all the steps, because if you go a little bit crazy, you'll still probably get working through marks. The other thing, this looks really tedious. having to go, well, 324.6 divided by 162.3 equals 2. I could do that in my calculator to show it though, because the examiner likes to know, well, that you know what you're doing. So you could get marks for doing that. Sometimes you have to prove it. There's just a couple of other points to note. Sometimes when you get to this stage, you get odd numbers. So, times to be careful.
Very quickly, why is it CL6?
Because I times both by 2. So FE times 2 and then CL 3 times 2 is 6.
Okay.
Yeah.
And then the normal mass, why is it 324?
I've just told you that.
Oh,
That's
will it say the normal mass?
Yeah, it will tell you that.
Okay.
So be careful. If you get to this stage and you get a ratio, normally it comes up as 1 to 2.01 or something like that, which is fine. But if you get this ratio, if you get something like 1 to 1.5, you can't round your 1.5 up or down. It's in the middle. How can I get around that? How can I convert that into a whole number? Any ideas? Sorry? Yeah, great. Times both by 2. So you times both by 2, and that would be 2 to 3, like so. The other one to be careful of, if you get 1 to 1.3, any ideas how I get rid of that? I times it by... If I times both by 3, that becomes 3 and that becomes 4. So if you get your ratio that ends up as 0.5 times by 2, 0.3 times by 3, they're the common ones that are going to come up at AS. Yeah, absolutely. So those are ones to watch.